We are going to take a look at a couple examples of using the limit definition of the derivative to find some derivatives. Now remember, the limit definition of the derivative says the limit as h goes to 0 of f of x plus h minus f of x over h is equal to the derivative of the function. This is basically the change in y over the change in x as that change goes to 0. We're going to start with just a simple linear function. So let's say we have f of x equals 2x plus 4. Then we just apply the definition. So we take 2 times x plus h plus 4 minus 2x plus 4. That'll in parentheses because it's the whole function. Remember, we're taking the limit as h goes to 0 of this. We divide by h. And then we just distribute and simplify. So this is equal to the limit as h goes to 0 of 2x plus 2h plus 4, right, distributed by 2, and then distribute that negative, minus 2x minus 4. We see, and this is still all over h. And we see this 2x and that 2x cancel, this plus 4 and that minus 4 cancel, and we're left with the limit as h goes to 0 of 2h over h. The h's cancel, leaving us with the limit as h goes to 0 of 2, which is just 2. So pretty straightforward when we have a linear function. We could look also at, say, a polynomial. So let's let g of x equal x cubed. Then we have the limit as h goes to 0 of x plus h cubed minus x cubed all over h. When you have a polynomial like this, so if you do a power, the best bet is to expand it. And you remember if you're doing a polynomial or a binomial, I guess, if you're doing a binomial and you're doing the expansion, Pascal's triangle gives you the coefficients of the expansion. So we have the 0, 1, 2, 3. So we're on a cubic, so these are our coefficients. So we have, this is equal to the limit as h goes to 0 of x cubed plus 3x squared h plus 3xh squared plus 1 h cubed minus x cubed all over h, which is equal to the limit as h goes to 0. And now all we have to do is simplify a little bit of this stuff. This x cubed and that x cubed go away, and then we see there's an h in every term, so we're going to factor one of those out. So this is equal to the h times the quantity, 3x squared, plus 3xh plus h squared all over h. And then this h cancels that h, and we are left with the limit as h goes to 0 of 3x squared plus 3xh plus h squared. Well, now we can let the limit operator operate because we won't end up with 0 in the denominator. And so as h goes to 0, this term goes to 0, and that term goes to 0, and we're left with 3x squared. So there's our derivative. Then let's look at a slightly different function. Say h of x is a fraction, say 1 over x. So then we do the derivative, the limit h goes to 0 of 1 over x plus h minus 1 over x all over h. What we want to do here is get a common denominator. And so we look at these terms, and we're going to give those a common denominator. So we're going to multiply this one by x plus h over x plus h, and we're going to multiply this one by x over x. And that gets us the limit as h goes to 0 of x minus x plus h all over x times x plus h all over h still from that one. Well, now we can simplify the top end because that's h over 1. We can multiply by the reciprocal, and this is limit as h goes to 0. X minus x, those cancel, that negative distributes to that h, so we have negative h over h times x plus h. And this h and that h will cancel, which leaves us with the limit as h goes to 0 of negative 1 over x times x plus h. But then we can let h go to 0, then we get this is equal to -1 over x squared.